Now let us see the concept of stack implementation using single linked list. Stack implementation using single linked list. We already know about this stack, which is a linear data structure wherein all insertion and deletion operations can be performed only through the top end. This top end. Okay. So now stack using single linked list. Stack with a list of nodes. Let us first discuss its structure. Like if the first node in the stack inserted is some 10. This is the first node inserted, and it will have its pointer, start pointer, and this is only the node we have, so its link part is null. And now once a node is inserted, this has to be referred with your top pointer. So for this particular node we have two pointers, start pointer and top pointer. Now a new node if you have to insert, so for this first node, its link part for this top, upon the top we will be inserting the new node as per the rules of stack data structure. So here we will get our new node and this will take 20 value and this will be having the link as null. But now what is the top of our stack now? This new node will act as the top, so our top pointer should be shifted to or passed to the top node. Like this top pointer should be modified every time you perform your insertion. This is about the push operations in the stack. What about our pop operation? Pop is that only the top referred through top pointer, whatever node you are referring, that is the node you can delete first. So to delete this particular node, it is that this is referred with top, so it can be easily deleted and you can free that node by using this pointer, top pointer, free of top. But the below node of this top should be treated as the next top. For that reason, while performing the push operations itself, every time you insert a new node, the previous node will refer with another pointer, previous pointer. So once this previous pointer is defined like this and the top node is referred with top pointer and the below node of that is referred with previous pointer. Now if you delete this particular top node, then your previous pointer referred node will become your top node. So this is the logic behind this. Now we will write the code for push and pop operations by maintaining the top pointer for it. So now let us see, for defining this push and we have to define our new node and struct node star malloc size of struct node. This is new node to be inserted and data is, assume that it is some 10, and here what other nodes we have to declare. It is that struct node, they should be declared as global only. So it is that struct node star n is 1 and our start is 1 and our top pointer and our previous pointer we have to declare like this. Now for push operation, here one more point is that earlier in the pop and push stack operations, when we are performing push operation, every time we used to check that whether that stack is full or not. Once if it is full, we can't perform a push operation. But here the case is that here it is not the array representation, we don't have that limitation. As it is linked list representation, dynamically new nodes can be inserted and we can extend the size of the list to any limit. So here initially we'll start with whether the stack is having any elements or not. To check that, if start is null. If start is null, indicating that there are no elements in the stack. When there are no elements in the stack, our new node n with data 10, it has to be inserted into our stack. So it is we have to make start equal to n. Simply for our start pointer we can assign n, and this node only has to become the top referred node. So your top also made assign with n, then your top link should be null. So this will be your null value and this n is no more now. So first node, if it is the first node we are inserting, n is directly assigned to start and top is n and top link is null. If it is the else case is that already one node is there like this. You have got your next n node to insert here above the top. As it is stack, earlier in the single linked list insertion at the end, we used to traverse the list from the start to till the last node, but here in the stack we are avoiding that procedure because already we have a top pointer which is referring to the top node in the stack. So simply referring the top pointer, the new node will add to the top. So here our new node is n. So here this is our top node. So now what we have to make is that this top link, now it has to refer to our new node. Here it will be added. For that, it is that top link equal to n. And now this has to be made as the new top. Further, to make this node as new top, what we can do is that by doing top equal to top link, we can make this particular node as top node. But before passing this top from the previous node to the next node, as we have already discussed, previous pointer also has to be stored. What let us do is that we'll store in this previous pointer the address of top, then we'll make top equal to top link. So with these two statements, this node can be referred with previous and this top node can be referred with top pointer, and the top link also you can make it as null. Top link you can make it as null because that is the last node. This you have to make it as null. So with this, every time like this, you can go for inserting, pushing new node into the stack. Now if you see it, deletion, it is nothing but your pop operation. Pop always what it has to do is, it has to delete the topmost element from the stack. So already here in this, we have already defined the previous node and we have already defined the top node. It's very simple to write the statements for pop. But for popping we have to check whether the singly linked list is empty or not. If start is null, we can say that it is empty, so there is no possibility to pop. No elements or no nodes in the list. In the else case, that is that now we want to delete the topmost node. So for that, what we can do is that we have to make this previous node as our top node. The top node to be deleted. So we have to use a temporary pointer here. Temp equal to top. We have to store the current top into a temporary variable. Then we can make top equal to our previous node. Top equal to previous node. So the previous node's address we have stored into top. So now this particular node is referred with top node, and now this node has to be freed. So you have to write a statement free of temp. So with this particular one statement, top equal to previous, this previous node has been made as top, and we could free this temp node. So with this we can perform our pop operations in the stack. Like this, singly linked list can be used for implementation of stack effectively.